slope of a line. So we've talked about graphing lines and looking at some of their characteristics. Now we're going to take a look at one specific characteristic of a linear equation. So when we graph a linear equation, we're going to talk about what's called the slope. And when I hear the word slope, the first thing I think about is skiing. And we go skiing on a ski slope. So if you think about that skiing context, this slope really talks about the same thing. So the slope, and we call the slope m of a line. If you think about the mountains have a slope. M is the slope of a line is a ratio, so it'll be a fraction, of the change in y, and we're going to talk about the change in y as the rise, over the change in x, which we're going to talk about as the run. So it's a ratio of y over x between any 2 points, and we're going to call one point xy and one x1 and y1, and the second point x2, y2 on the line. There's a lot of stuff in there. So m is our slope, and we write slope as a ratio of y over x. So how does y change over how does x change? And we talk about 2 points on that line, and we just identify the x's and the y's. Notice this little 1 at the bottom. It's not an exponent. That 1 just clarifies as these x and y coordinates are from the first point, and these x and y coordinates are from the second point. So slope, we use the letter m to represent slope. Again, think about the mountains, mountain slopes. We talk about the rise over the run. Rise is going up and down. Run is going side to side. And if my slope formula, which is this here, I can take the y value of my second point, subtract the y value of my first point, over the x value of my second point minus the x value of my first point. We're going to put this into action and see how that works. So first let's take a look at a graph between 2 points. So I'm going to talk about these points 1, 2, and 5, 7. So on my graph here I have point 1, 2, and I have point 5, 7. Now if I talk about the slope of this, first of all, we talk about the slope. We always think about slope going from left to right. And this is a slope if I go from left to right. If you think about you're on a ski slope, this would be going up the mountain. This is a positive slope. So we're going to describe that slope with a number to describe how steep it is, but that number should be a positive number because this line is a positive slope. Alright, so when I go to describe the slope, again I'm going to talk about the rise over the run, the rise over the run. So one way I can figure out the slope is to actually move around on the coordinate plane. So I'm going to start at 1 point, and I'm going to trace a path to the second point. So if I start here on 1, 2, and I could have started on 5, 7 and gone backwards, that's fine. If I start here on 1, 2, I'm going to only move vertically and horizontally. So if I do a rise here, I go up 1, 2, 3, 4, 5 points. So that's up 5 points. Moving up is positive, so that's a positive 5. And then to get to my second point here, I have to do a run of 1, 2, 3, 4 points, and that's to the right. So the right is always moving toward my positive numbers. So I have a positive 4. So I have a rise of 5 and a run of 1. I could also think I'm going from 2 to 7, that's 5 places. And from 1 to 5, that's 4 places. So I end up with a rise of a slope of 5 over 4. I rose 5 and I did a run of 4. Positive 5 over positive 4. 5/4 is a positive slope. I'm going to leave it as a fraction because remember we talked about slope as a ratio, just 2 numbers. This is a positive slope that's fairly steep. So one way to come up with the slope is directly from the graph. Now a second way to talk about the slope is to talk about your slope using what we call the slope formula and using the 2 points that I've been given to just do the math. So I don't need to actually draw out a graph. So how I do that is I take one of my ordered pairs. You can start with either one, totally up to you. I take one of my ordered pairs and I'm going to plug it into the formula. Now how I usually do this is I do 1 point at a time. I'm going to take the y value and plug it into my numerator. And I'm going to take my x value and put it underneath it. So I've started my ratio like that. I just worry about the 2 and the 1. Y value on top, x value on the bottom. Then I do subtraction. And then I take my second ordered pair, 5 and 7. I put the 7 on in my numerator, and I put the 5 underneath it. So I should be able to look and see that this is one of my ordered pairs stacked right on top of each other. Y on top, x on the bottom. And this is my other ordered pair, again stacked on top of each other, y on top, x on the bottom. So from here I'm going to do my math. 2 minus 7, that gives me negative 5. 1 minus 5, that gives me negative 4. This is a negative divided by a negative. I always simplify that. And a negative divided by a negative gives me a positive 5 over 4. So notice I figured out the slope 2 different ways. One using the formula, and one using the graph, I had the same slope both ways. I got 5 over 4 both ways. So I should come up with a slope, the same slope either way, whether I do it from the graph or I do it from 2 points. So again, my slope is my rise over my run, and it's describing how steep the slope is. All right, let's try it from a few different given situations. So let's find a slope from a graph, from ordered pairs, and from a table. So from a graph, again, if I'm looking at the graph, I can go directly from the graph, just counting the rise and the run. So I'm going to start at one point here. I'm starting at negative 2, 3, and I'm going to move over to 3, 2. So I'm going to go do a rise of negative 1 since I'm moving down. So I'm moving down one place, so that's a negative 1. And then I'm going to have a rise of positive 5. I'm going to count my way over. I have to go 5 places, so I'm going to count my way over 5 places. So I have a rise of negative 1 over a run of 5, which gives me a slope of negative 1/5. Now, if I look at that line, it makes sense that that's a negative line. Because again, if I think about my ski slope, if I was going from the left to the right, I would be coming down the mountain. So that would be a negative. So I should have a negative slope, which I do. All right, my next ordered pairs. I have negative 3, 1, and I have negative 5, negative 4. Now, if I give myself a quick coordinate plane, I don't get real picky here. Negative 3, 1. Negative 3, 1 is going to be up there. And negative 5, negative 4. Negative 5, negative 4 is going to be down here. So I want to pay a little attention to, well, what kind of slope is that? Well, negative 5, negative 4 will be further out. So this is going to be a pretty steep positive slope. So again, when I do this, I'm going to pay attention to one ordered pair at a time. Here's my formula, y2 minus y1 over x2 minus x1. You'll eventually have that pretty solidly without having to think about it anymore. I'm going to take my first ordered pair, and I'm going to put the y on top of the x. Then I'm going to put subtraction. Then I'm going to take my second ordered pair and put the y on top of the x. Y on top of the x. So here is my second ordered pair. From there, I'm going to do the math. So 1 minus a negative 4, I'm going to change that to 1 plus 4. Negative 3 minus a negative 5, I'm going to change that to negative 3 plus 5. That gives me 5 over 2. So fairly steep slope. And our last example here, I can do this from a table too. Remember that a table is just a little list of ordered pairs that are solutions to an equation that form a line on a graph. So since these are all ordered pairs on that line, I can use any of the ordered pairs that I want. So pick two that seem friendly to you. I picked the first and the last. You could have picked the first one and the second one. Any combination of two ordered pairs will give you the same slope along that line. I'm going to use my formula here. So again, I'm going to take my 2 and my 1, I'm going to put y over x. I'm going to take my 11 and my 7, y over x. I'm going to subtract. I get negative 9 over negative 6, which when I simplify that, negative divided by negative is positive. 9 over 6 gives me 3 over 2. So I end up with a slope of 3 over 2. So thinking about our slope, thinking about our ordered pairs and either plugging them into that slope formula, or thinking about it as on a graph, our rise over our run.